Hello everyone. Welcome back to the second and last session in this introductory Unity workshop. Since this is the second session. I'm not sure if introductions are really necessary, but if you're new, hello, my name is Waza, and I'm going to be taking you through this course today. So if you didn't watch the previous session, I just recommend you go back and watch it. But for everyone who was here yesterday, the other day, welcome back. Okay, so just bring up my screen. Okay, so we're going to continue with the game we started building in the previous session, and the main where we ended was we made this obstacle here that just moved towards the player. So when I click play again, Unity do not disappoint me. Okay, so when I click play, it moves at a certain speed, right? But so at the end of the previous session, I said the first thing we're going to do is that we're going to randomize these so that the pattern of these three obstacles always appears different each time you play the game. So and just so we can give these obstacles some differentiation, let's just add some color. I'm just gonna color these red, and for my bounds there, I'm just going to give these a grayish color like that. Okay, so you can just give the player a color of blue. Okay, green will be fine. Okay, so how will we randomize this? Well, we will go back into our script. We'll go back into the script right here that we had created in the previous session that handles the moving of these guys. So in this session, I'm just going to teach you how to create, how to randomize things. So the first thing we're going to do is that we're going to, we're going to say public. Um, we're going to say public list, and okay, we're going to use an array. So we're going to say public game object. So we're going to have a game object array called obstacles. Called obstacles. We're going to have that game object array called obstacles right there. And then at the start is where we're going to do the randomization. So what we want is that we should always have at least one obstacle enabled and at most two, right? So I'm going to say int we're going to make it public. So public int max. There will always be a maximum of two obstacles that will be enabled whenever the game is running. So what I'm going to do next is that I'm just going to say for, so the number for loop for int I being equal to 0, where I is less than our max there, we're going to say I plus plus. Okay, so how do we go about randomizing stuff in Unity? Well, you can do it in two ways. If you're familiar with C#, you can use a default the random class that's provided in when you say using system. You can use this default random class, or you can use the one that Unity provides, which is the one we're going to be using today. I'm not really sure of the exact difference, but I'm used to using the one that Unity provides. So yeah, so we're going to say int index, we're going to call it index, is equal to random dot range. So you say random dot range, and then here you pass in a lower limit and then an upper limit. In this case, max. We're going to, in this case, we're going to say our obstacles dot length. So we're going to get the length of our obstacle array, and so this is exclusive. The last one is exclusive, so we're going to get 0, 1, and 2. Those will be our indexes, and then we're going to say obstacles, and then at the index. Now this guy is will give us back will give us back a game object, and the game object has a useful property on it called set active. So a method on it called set active that either enables or disables the object from our scene. Now, there's a difference between enabling an object and then completely destroying it or removing it from the game entirely. And we'll actually talk about that a bit later on. But then we're going to say index set active, and then we're going to set this active to true, right? We're going to set active to true. And what this is basically doing, if I go back into Unity, um, let's just compile my scripts. Let me just make sure I am in this thing for you. Okay. I just wait for those scripts to fully compile. Let's not have a repeat of the previous session. I hope these are done in a few seconds. Okay. Okay. So what set active does is basically whenever you click on a game object, right here at the corner here, there's this button that either enables or disables it from the scene. So when I click that, that enables or disables it from the screen. So what set active does that it actually just lets you trigger this within your code. So remember, these things are just classes. So almost every property that these components have, you can manipulate it in one way or another through code. That's the power of well, the component approach of Unity. So what we're going to come and do now is that I'm just going to lock that there. Hopefully I don't forget to unlock it this time. And then we're just going to drag and drop our objects right there. So yeah. And okay, yeah, in the previous session we had actually discussed the meaning of all this. But if I run this game, what you notice there, okay, we'll have two of them being spawned. If I try and run it again, as you can see, if I run it again now, we only have one of them appearing, and this is completely random. So we'll always have at least one obstacle that appears, or at most two of them. So the player is never blocked, or they never have something to not well try to fight against, try to dodge. I mean, so now that we have this, the next thing is we want to spawn these obstacles continuously, right? So how do we do that? Well, this is where I'll introduce to a couple of things. The first is prefabs, followed by how to instantiate an object, and then we're going to look at this guy over here, a timer, how to create a simple timer in Unity. So what I'm just going to do is that I'm just going to create a folder, and then this folder I'm going to call it prefabs. So what prefabs are basically instances of objects, and what I mean by that is that instead of me having to duplicate this obstacle and then I come and duplicate it again like that, what you can do, the problem with doing this is that any changes I make to this obstacle will not affect this obstacle right here, right? But with prefabs, it's more like creating a template that this object will follow. So whenever I make one change in one prefab and I apply it, that change will apply to every prefab. So you can imagine this, and say you're making a game with, let's say, hundreds of levels, and then you have one prefab. So if you're not using a prefab, if you made a change to one thing, you would have to go through each of those levels trying to change it. But with a prefab, once you make a change to one prefab and apply it, that change will be applied to all the prefabs in your entire game because all of them reference one object. And to create a prefab, it's just a matter of getting an object from your hierarchy like this, holding it and then dragging it into your project window there. And this automatically creates it as a prefab. And you can see the color there even changes. So um, let me just enable these guys right here. So say I come on and do this. Hopefully my change makes enough sense. So yeah, I applied this change of enabling these on one prefab and it applies them to everything. So if I come and disable, say, those inner obstacles right there, and then I apply it here. So yeah, it does that. It's a simple thing, but hopefully get the power or that these prefabs actually award us in our games. So I'm just going to delete these. We're going to bring them back in another form, but I'm just going to quickly create a new empty game object, and then I'm going to call this game object obstacle spawner. I'm going to call it obstacle spawner like that, right? So I'm going to call it obstacle spawner, and then we're just going to add the component that yeah, we're just going to call obstacle spawner. So obstacle spawner. And then we're going to be using this now to spawn in objects in our scene. I'm just going to go edit script, Unity, and it's compiling our scripts. Okay. Okay, so let's wait for that stuff to start responding. Come on. Okay. Okay. So yeah, we are in our obstacle spawner script, and in the obstacle spawner script, we're going to need two things. One is the object we're actually going to be spawning, right? And you can do spawning. You can. It's fine. We're going to say public game object. So public game object, and then we're going to call that obstacle to spawn, right? We're going to call that obstacle to spawn. So how do you spawn an object in Unity? So I think it's going to say public transform transform spawn position. Public transform spawn position, and then in my update, just for the sake of testing, I'm just going to say if input dot get key down, and then we're going to say key code dot key code dot space, right? Key code dot space like that, and then the method we use when instantiating an object, as it is called in Unity, or in common terms, spawning an object, is instantiate, right? And then instantiate, there are like 10 variants of this method, but the most common one that you might use is, first of all, you pass in the prefab or the object that you want to the game object that you want to spawn, or the transform that you want to spawn. In this case, we're going to say obstacle to spawn. That's the object that we want to spawn. Next thing is the parent, right? So this is one method of doing it, where it will spawn it relative to a parent. So you've seen the way we're parenting things, so this will automatically parent an object. But what I like to do is that I like to specify the position, so spawn position like that, and then a rotation of the object. Now, since this object, we just want it to spawn with a uniform rotation. We don't want to rotate it in any funny ways when you spawn it. I'm just going to say quaternion dot identity. You don't need to know what a quaternion is per se, but all you need to know is this will just spawn it with a default rotation. And here it's supposed to say transform dot position, because that's the entire transform, and we just want the position of it. So this is how you spawn an object in Unity. Just use instantiate, and this returns a game object. And by returning, I'm pretty sure you know what return type is in programming. You can basically just come and say game object obj, and then it's equal to that. So in case you want to assign this object, this game object to something later on, this is how you can do it. You can just come and assign it to a variable over there. So if I come back in there, and we have that there, and yeah, so on object to spawn, the only thing I have to do is come and say, okay, I just drag it in there as object to spawn, and then for the spawn position, I'm just going to use the object spawner itself as a spawn position. Then I'm just going to drag its reference all the way there, like that. Just gonna save that and just make sure I'm still in the stream. Okay. um Let me run that. So every time I hit space, we're going to spawn an object, right? Every time I hit space, we're going to spawn something new. And that's how you instantiate an object. So all the logic, whether you're making an FPS, as long as you want to spawn something into your game mode, that's how you do it in Unity. You just need to give it what object you want to be instantiating, and yeah, to be doing that. So just a matter of meet up in space like that, and then that object will be spawned in the world. Now, for our game, we obviously want this to be done automatically. We don't want the player to choose when they want to spawn an object, right? So we don't want the player to come and do this there, and then they do that there, and all the like. So we want the player to choose when they want to spawn this object. So how we do that? Well, to achieve this, what we're going to do is that we're going to use a timer. So I'm just going to use something called the header here. I'm just going to use something called the header. And this is just an attribute. This is just an attribute in Unity. This is just an attribute in Unity that lets you declare a header. I'm going to show you that in a bit. So I'm going to say public float. Then I'm going to say spawn time. Just going to say spawn type like that, and then I'm going to say private float time between spawns. Time between spawns like that, right? That's what I'm going to do. And what this header does, let me just go back into Unity real quick. Okay, so if I go back like that, what this does is that we're going to have that header there that just appears in our inspector, and it's just sorry, just pardon me for a bit. I am so sorry for this. Sorry for that. So what we're going to do is that this spawn time, what does that? It dictates. We're going to use this to dictate a time in between our spawn. So we're basically just going to tell Unity to say, okay, always spawn this object after a set number of seconds, right? In this case, we're going to say, okay, spawn after 5 seconds. Now, how do you incorporate a timer into your game? So in our update, I'm just going to get rid of this guy. Right? I'm just going to get rid of this guy, and then I'm going to say if time between spawns, right? Time between spawns is greater than or equal to spawn time. So remember, we don't compare floats directly. What I'm going to do is that I'm just going to move this guy right up here. So if our time in between spawns is greater than our spawn time, we're going to spawn a game object. We're going to spawn this game object. Then afterwards, I'm just going to say time between spawns. I'm just going to set that equal to 0 right at the beginning, right? I'm just going to set that equal to 0. Else, what I'm going to do is I'm going to say time between spawns plus equals time dot delta time. Now, what is this time dot delta time? This is a very important thing. So, computers run at different frame rates, right? I can't just come and say, I can't just come here and say plus equals 1. Because remember, the update runs every frame. right? So some computers might run this game at 60 frames per second, some might run it at 30 frames per second, some might even run it at 2 frames per second. And that means our game will not be consistent. So what we do is that we use this time.delta time variable, and this is just a variable that measures the time in between frames. So the time in between the current frame and the previous one. So delta, the change in time. So between those frames. So this means that no matter what your frame rate, this time dot delta time will always be relative to your frame rate, but in terms of real world time, it will always be constant. What this means is that it's independent. Basically, it's independent of it will be fully independent of whether your PC has a low frame rate or a very high frame rate, right? Am I muted? Okay. Yeah. So, yeah, I'm sorry if I keep on checking back there. I have a very poor internet connection, so I'm just a bit anxious. You might find that you were booted out of the stream a long time ago. But yeah, so what I'm gonna do now is I'm gonna say I'm going to run that. So in fact, before I even run that, at the start I'm just going to say time between spawns, equal to spawn time. And I'm just doing this so that we don't have to wait 5 seconds to see the first game object spawn, right? So just going to wait for Unity to compile that. Okay, so and what we're going to notice that so this one spawns automatically, and then we're going to count for a few more seconds. So these objects will always spawn every 5 seconds. Will always spawn a new object every 5 seconds, right? But 5 seconds appears to be a bit too slow, so I'm going to set it to 3. Let's set it to 3, and so every 3 seconds, 1, 2, 3. Okay, so these objects always spawn every 3 seconds, which seems to be a better time. And of course, programmatically you can set it where after some time this rate decreases. Let's say we take it down to like every 1 second, although that makes the game very impossible unless of course we go in and change the actual speed of these obstacles. So if I was to come to my obstacles and say our speed is something like 2. This is adjust some variables in the game just so we can see how things go. Okay, so yeah, now the game does not seem very slow, and yeah, we're having something that is resembling a game, I can say. Yeah, we might just want to move that spawn position a bit off screen, and then yeah, so we have something slightly resembling a game here. Now there are two problems with our current setup at the moment. Right, yes, this is working. um the problem is these guys that were spawning over here, they just keep on going into the void until infinity. So yeah, these things will just keep on going into the void until infinity. And then another thing, every game obviously has a score, and our game currently has no score. So in the next part, I'm just going to teach you about two more things. The first is communicating between scripts, how you can communicate between scripts. The other is actually destroying objects. And the easiest one to implement now would be how to destroy objects. Now, this logic can be handled anywhere. We can handle it in the obstacle script itself or the obstacle spawner. But I'm just going to handle it in the obstacle spawner itself. So what I'm going to do is that in the obstacle spawner, I'm just going to say destroy, and then I'm just going to say obj like that, right? Now, just calling destroy obj like that will destroy it immediately, right, on that same frame. So what we're going to do is that we're going to specify a time. Now, in this case, I'm just going to go off on a guess and say that after 15 seconds, this object will be completely off screen, and then we can destroy it properly. So you can, of course, there are multiple ways of actually doing this. For instance, in our obstacle script, we can check on update whenever this obstacle is actually a distance away from the player. We can always just destroy it then and all the like. But yeah, there are multiple ways of destroying things. But this is just a quick way of implementing it. What did I do there? Well, excuse me, where we can just destroy this object immediately after a certain time, so after 15 seconds. So whenever I spawn an object, we just create this destroy routine for it, and that will just destroy it after some time. So um what we're going to notice now is if I come and hit play there. Did I even save my script? Okay, it was saved. Just going to go to my object spawn right there, and then we're going to keep a close eye onto this object that we spawned here, and at a certain point it should disappear. Okay, yeah, as you can see, so at a certain point these objects are disappearing, so they are being removed from our world. Now there are some arguments to the efficiency of directly destroying an object, but we won't go into it for now. I won't go into it now. There are other ways of doing this, of course. You can use an object pool, but that's a bit beyond the scope of what we want to cover today. So, um, now that we've done that, the next thing we're going to do is we're going to create a way in which we can actually keep the score. Now, there are multiple ways to do this. I want to avoid using singletons because, as much as I like them, I've heard they're not a very good pattern. But yeah, I want to avoid using something called singletons here. And then I'm just going to use a certain method that we're going to use to keep track of the player score. Now, we can come and create a class called player score. That we're just going to say player score counter. Right, we're just going to say player score counter like that, and wait for the infinite compilation of code. Okay. um, yeah. Okay. So we're just going to wait for that to happen. Okay. So so what we're going to do. Okay, Visual Studio Code do not. Um, why is everything? Oh, and sorry for the noise. I'm on a college campus, and today is a Friday night, so yeah, yeah. Just heads up on the background noise. Okay, so seeing that is fully loaded in, what I'm going to do is okay, come on, Visual Studio, come on, do something. Um, okay, mm, where is it? I think everything. Okay, so we're going to go into our player score counter like that, and what I'm going to teach you before even going to UI is how you can communicate through our different scripts, because whenever we're making our game, we're going to have a lot of different scripts in our games. Like one of my projects at the moment has over 100 scripts, so and that's actually very small. But yeah, so you can have hundreds of upon hundreds of different scripts in your project. So I'm just going to show you how you can easily communicate between the scripts. So what I'm about to show you can apply for anything. Yeah, so Visual Studio's IntelliSense already knows that I want to add score there. But then what I'm going to do is I'm going to say public void add score, right? I'm going to say public void add score like that. And then what I'm going to say is that we're going to add a score of, just going to say score plus plus. Okay, wow, Visual Studio and its intelligence. So I'm just going back in. I'm just going to go back into this guy over here and set it to destroy after 6 seconds. Okay, I'm just going to set it to destroy a bit faster. And what I'm gonna do is yeah, how to communicate through scripts. So we're gonna have something here. We're gonna say now. Remember, scripts are just classes. They are not. They are a data type. So I can just say public player score counter, and then we're going to call it score counter like that. And simply by doing this, I have access to every public. I have access to every public variable and method in this script, and that's how you communicate through scripts. So you can of course use the get component and do like, but this will just let us drag and drop this in the editor, and then within my obstacle, I'm gonna say what I'm gonna say is I'm gonna say public obstacle spawner. Now making everything public again, it's a bit debatable, but again, for the sake of this introductory session, we're just going to be making everything we can public, unless we don't have to, but which we don't, but yeah, we're just going to make everything public for the sake of this introductory session. So what I'm going to do, I'm going to say obj dot get component, and remember in the previous session the get component just lets us get a component on our object. So we're going to say obstacle, we're going to get that obstacle component dot, and then I'm just going to say um spawner, right, equal to this. And what this does, this in object oriented programming, is the current instance. It's this class, the instance of this class, and that's what we're going to assign to this variable whenever we spawn that object. Now, why am I doing this? um why am I doing this? Yeah, so why I'm doing this is we're gonna say, obstacle spawner like that, this guy on the update. Now there are a lot of ways we can do this, and I'm just gonna say I'm gonna do a bit of math. So I'm gonna say public void check for, okay, I'm gonna say up. I'm just gonna put this in the update method. Update again. Don't always put things in the update method, but for our purposes here, it's going to be fine. So let's say public void update. So okay, so in our update now, the only thing I'm going to do is that I want to check whether the player is above our object, and I'm just going to do this with a bit of math, just a tiny bit of math. So what I'm going to say is vector 2 dir. In fact, I'm going to vector 2 dir. We're gonna set that equal to yeah, the vector 3. So vector 3 is just a 3D vector x, y, and z. So I'm just going to do a bit of math in which to check whether the player is actually above our object, and this is going to require me to have reference to the player. Okay, luckily we know this player score counter will always be attached to the player, luckily in this case. So I'm just going to say um what I'm going to say is I'm going to say spawner dot uh dot score counter dot transform, right? Get the position of the player dot, so dot position like that, to get the position of the player. And then what I'm gonna do, um which one is I'm gonna say minus the current transform dot position like that. And what this is going to do is that we're basically going to say this is more like the center, and then we're just going to get the displacement in short. So we're just going to subtract the player's position from the current position, and this will just give us a direction in which our thing is. So we're just gonna say dot normalized to make it a normalized vector. Yeah, I'm doing a bit of vector mathematics here, but hopefully I'm not losing people. Anyway, you can always ask me via Discord, but yeah, this will work. That's what we'll say. So I'm gonna say that if dir and vector three is also a class, and it has we can access the x, y, and z component. And in this case, to check whether the player is above something, all we want to do is that we just want to say y, right? Vector two dot dir dot y is greater than, and to check whether the player is above, we're gonna say is greater than one, right? So if it's greater than one, it means the player is right above us. Yeah, I know the math might not make much sense, but in this case, I think we can even handle the destroying logic in here. But anyway, it's fine. We're gonna say spawner dot score counter dot add score. So since the player is above this object, we've already passed through this obstacle. We can easily just add the score now, right? Yeah. So I'm gonna do that, and back in Unity, please compile. Yeah, the weight. Okay, wow. Okay, so we're gonna say score there, and then in our obstacle spawner, what I can do now is that this, since I said public score counter, what this lets me do is that I can just drag in anything that has a score counter in here. In this case, what has a score counter is my current player object. And I'm just gonna say score counter, boom. So we shall do that, and hopefully, if all my logic is right, I'm then just gonna leave this here. In fact, just so I can show you one quick thing that we can do in our score counter, I'm just going to say console.log, 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 and then we're going to say score. Okay, so why? Oh, sorry, not console, debug. JavaScript. Debug.log score. So we're going to just debug that. We're just going to print out that score, and let me just make that completely lowercase. Okay, so we're just going to show that score right in our console. So this is how you print stuff out to the console. So the console isn't just used for viewing errors. You can also use it to debug your code in your game for other errors, that is. So I'm going to just run that. I wish I could view the chat right now to see if there's anyone asking any question. So we're just gonna do that. Um, okay. So something doesn't appear to be working, and I have a feeling it's my math. So yeah, instead of us spending too much time debugging this, instead of us spending too much time debugging this, what I'm going to do is that I can just cheat and say this was part of the plan and introduce you to another something else that we can use. So I'm just going to say on destroy. So there are a lot of different methods that these things have, and assuming I'm using it right, on destroy should be called whenever we close this object right here. Yeah. So whenever we destroy the object this is seated on, so we can just have a function is called whenever the mono behavior will be destroyed. Okay, so and to even okay, mm, I'm hoping my logic is right for all of this. Otherwise, this is very simple logic. Okay, yada yada yada. Okay, and yeah, so whenever that object gets destroyed, we always add something to our score. So yeah, we have scores happening, right? Yeah, we have scores and all the like. So in this remaining 20 minutes, we're going to do something really fast. So I'm just going to show you how to create UI. And the way you create UI in Unity is simply just go. You don't have to manually program the UI. At least you can always just drag and drop everything. And there's of course a new UI system. Am I still in the stream? Again, poor internet connection. I just need to make sure. So I'm gonna say UI, and then I'm just going to add a text mesh pro. So import essentials, and text mesh pro is just a text system. So yeah, I should have imported this before, but anyway, okay. Anyway, at least we get to experience the paint together. Just wait for that. Okay, we need to review my Unity settings because this is not normal for me. Okay, now that we have that, we have two things that were created, three things in fact. We have a canvas, and a canvas is where your UI components sit. And then we have our actual UI component, and then we have an event system. And don't worry much about this, but this is just what handles any UI events. You can do a lot of fancy things with this guy, but what I'm going to do is that we're going to scale this canvas, right? We're going to scale this canvas. Now, there are multiple ways to scale it. First of all, we're going to set it equal to camera, and this will render on top of our camera, something like that. And um, when I go there, so yeah, it's size to our camera, and then for size, canvas scaler. This is how you change the size of your canvas. Now you can make it a constant pixel size in case you're making this canvas where it is an actual UI in the world. So you're not restricted to one canvas. You can use as many canvases as you want. But in this case, we're going to say scale with screen size, and this will actually scale based on the size of the screen. And then we're going to say 600 by 800, like that. So in fact, I'm going to say 10 by 16, 10 by 16, and then multiply that by 60, and then multiply that again by 60. I'm assuming the math will work. Okay, yeah. So what I'm just gonna do now, okay, so I'm just going to set this to the center of the world, and then the way you center this, that you click on Alt, you click on this component, and then you just go and click on the thing there, right there. That's how you center. And then I'm just going to adjust this guy a bit. So using my rect transform, I'm just going to increase that, and then it depends with how you want to, of course, style your UI and all the like. I'm not a UI UX designer, but for me, I I'm just gonna do this. Gonna set it equal to a big big zero. So I'm just gonna say 99 like that, 99, and then I'm going to set it equal to. I'm going to set the size to as big as this box will let me. So yeah, it's just equal to 100 like that, and then yeah, a big score of 100, and then I'm going to just set that equal to a very dark color, and all the way back in my back in my camera, in case you don't want to be looking at this ugly blue background. I mean, it's not very ugly, but yeah, I can just adjust this to look something like that. Fun fact, most of my games are all made with shapes up to recently, the current game that I'm working on. I'm just plugging myself a bit in there, but yeah, hopefully I'm allowed, but you can subscribe to my channel. A shameless plug, I know, but yeah. So I'm just gonna set that equal to 175, and hopefully this does look nice. We're not using a color palette or anything. So what I'm gonna do is show you how we can manipulate this text. Of course, you can always it's just how you this is how you work with text. You can always come down there. You can move stuff around. You can change the size. You can change the color. As I've done it there. You can always change the gradients of your text. You can do a lot, but we're not going to dive deep into it. But this is you can play around with this to change your text a lot. So what I'm going to do is that we're going to go back into our text, and to work with UI, there are two things that you can use. You can use using Unity Engine. You can use Unity Engine.ui like that. Unity Engine, it gives you access to all the Unity Engine UI components except for one, which is Text Mesh Pro. So to access Text Mesh Pro, I'm going to say using TM Pro. gives us access to text mesh pro, and then I'm just going to say public text mesh pro UGUI there. This gives us access to a text mesh pro GUI object. So there's just text mesh pro. For text mesh pro, the actual text that we're using, it can be word text or it can be UI text, but in this case we're using the UI version, so I'm just going to say that. And then I'm just gonna come and say score text, and the way we're going to set the text of this, we're just going to uh say right at the beginning, start score text dot set text there, and then we're going to set it equal to a big fat 0. So you always have to pass in a string there, so 0. And then what we're going to do now is I'm going to say score text dot set text like that, and then we're going to say score dot to string. This will convert our value into a string like that. So score dot to string, etc., etc. There are other ways of doing it, but okay, this is just the fastest way of doing it. But yeah, when you have like a couple of minutes left, score text dot UI, and then yeah, I'm just going to go back into my guy over here, and then I'm just gonna say boop, add that there. So we're going to add that reference to our score text, and then when I run my game, as you can see, yeah, we have UI there in the world. Yeah, things are happening. I can say we have something relating to a game now. Yeah, so you can always go add that difficulty curve and all the like, but yeah, this is how you can make a very basic infinite run. Yeah, this game is infinite. It can go on. You can go on forever and all the like. But what we're gonna do now is that we're gonna add a lose condition. We want the player to lose at a certain point. So how do we achieve that? Well, first of all, this canvas, I'm going to set its layer to negative 5, and order in layer. This is something that you see on the sprite renderer components and all the like. And just to explain this guy a bit, layers are more like how these sprites are layered together. So if you've worked in image editing software like Photoshop, you see that there are different layers for different sprites and all the like. Then let me just quickly check there. Okay, so there are different layers for different images. Like you can have one layer that's handling the background and all the like. So you can place these images on different layers. And just to demonstrate, I'm gonna copy my player and then set that equal um red there, right? So if I reduce the layer, what you see is that the green one will be on top, but if I come and increase the layer and then go above, of course, so since everything is at layer 0, but if I come and increase this to layer 1, of course it will be on top. -1, that will take it behind this one that is still on layer 0. That's how layers work, similar to how you would work with them in any image editing software. So what I'm going to do is just going to show you how to test for collisions, right? Everyone loves collisions. And to test collisions, this is what we're going to introduce something called tags. Now, tags is one of the ways in which you can group objects, more like identify objects of a type. So tags are more like, you can say something is tagged player, and that would be like the tag of that game object. I don't know how I'm going to explain it properly, but it's more like an identifier, like a rank, a role that that object plays, not specifically, but it's like an identifier for that type of object. So we're going to tag this as player. This is just by default, but you can always add your own tag. You can just go there. You can call it car if you want. You can call it building, whatever. And I'm going to show you how we're going to actually use these tags when testing for collisions. So I'm going to say, okay, we're going to tag that as player. Now, where are we going to use this? Well, in our player script, I'm just gonna go back into my player script real quick, and then I'm just gonna do this. I'm just gonna say public void end game like that. So the we can either test collisions on the player object on the player itself, or we can test collisions on the obstacles. It's a matter of preference, but I can't say which is better than which. I'll just recommend you go and experiment. But in this case, let's test collision on the actual object here, the actual obstacle. And to do this, okay, in fact, let me just test collision in the player. Yeah, so whenever it collides with an obstacle. So, um, since we're going to be doing that in the obstacle, I'm just going to open that, and this is, you just double click your prefab in order to view it, like to edit it alone in its own context, so outside of your scene. Just double click it from anywhere. So I'm just going to do that, and then I'm going to say, I'm going to tag these. I'm going to go add tag and say, I'm going to say obstacle like that. I'm just going to copy and then save that tag. Now, what I'm going to tag these guys, I'm going to tag them as obstacle, and it appears under that drop down. Okay, so when I go back into my player object, what I'm going to do is that there are multiple ways you can test for collision. You can test for collision in 2D, in 3D, however. So the way you test for collision is using a method called the on collision, and then it can be on collision enter, on collision stay, on collision exit. These all mean different things. So on collision enter 2D. Since we're working in a 2D environment and these are going to be 2D colliders, we're going to work with on collision enter 2D. Okay. And what this does is that it triggers an event whenever this object collides with anything. The moment it collides with anything, just it triggers this event. So you also have on collision exit, which is when it stops touching an object, and then on collision stay when it is touching an object. So it depends on when you want to use it, but for now, just whenever we touch that object, we want to do something. In this case, we're going to say if collision, and collision, that gives us the name of that gives us a reference to the collider or the collision that we are currently the object that we're colliding with. Collision dot game object, find the game object that we've collided with, dot compare tag, and compare tag lets us check whether this object has a certain tag. We're going to say I'm just going to paste the tag that we have there. So our tag is obstacle. That's the tag that we gave those. And then we're going to say, whenever we collide with something called an obstacle, we're just going to say end game. I'm just going to call our end game method. And then here, just say debug.log. And then we're going to say game over. Game over like that. Right? Just going to say game over. And yeah. Okay. And now to run that. Okay. Oh my, oh my, oh my, oh my. This is not supposed to happen. I forgot to disable everything. Okay. Yeah, let's go back. Okay. So we're gonna play our game normally. We dodge those things there. But then if I come and hit that, should get game over there, right? Whenever we collide with something, we should get game over in our thing. So how are we going to go forward now that we're able to trigger this game over event? We're able to check, okay, we've collided with an obstacle. How are we going to end the game? We're just gonna go for a very simple thing. I think I'm running out of time. Yeah, so I'm gonna say public game object, and then this game object, I'm gonna call it end screen. Right? I'm gonna call it end screen. Now, there's a lot of logic that goes into this. Of course, we need to go through and then pause everything that is dependent on the player being around. For instance, when the player collides with something, of course, we need to stop this from happening and all the like. But the only thing I'm gonna do here is we're gonna say end screen dot set active to true, and then we're just going to enable something that happens whenever the game ends, and then I'm just going to set time dot times. In fact, I shouldn't be doing this in this screen in the first place, but okay, yeah. Okay, so now I'm going to create another canvas. So we're going to call this score canvas. I'm going to call this score canvas, and then we're going to just create UI, create another canvas, and then the way you copy components in Unity is just right clicking on it and clicking on these three dots right here, and then copy component, and then in the canvas there you say look for the other component that you want this to apply those settings onto, and then you say paste component as new or paste component values. In this case, I want to paste the values. I was going to do that, paste the values, so that this new one that we're adding is not very different from the one that we currently have. So copy component, and then I should have just duplicated it, but anyway, values like that, and then we're going to set it equal to, we're just going to set its order in layer to 10, and then over here I'm just going to create something called a panel. So panel is more like an overlay, and then yeah, I'm just going to set that to a red color, and then in there I'm going to add text mesh pro text, and say gonna center it over the place. Then I'm gonna say game over, game over, like that. Then I'm just gonna increase the size of our text and then make it a brighter red. Okay, so meaning to make it a brighter red. Yeah, game over, like that. Something very simple. We're gonna make it bold. Yeah, game over. Pom pom pom. Um, yeah. But then I'm just going to choose what are we going to enable. What are we going to enable whenever the player dies? In this case, I'm just going to say, this guy over here, this canvas right here. We're gonna say game object canvas like that, and then we're going to enable that whenever the player hits the bucket. So yeah. Have our score there. Score is going to increase after some time. Yay, yay, yay. Our score increases, and boom, we crashed into something. Game over. And yeah, of course, we would need to disable stuff like the score actually increasing, and us actually having to create, actually having to save a high score. Those aren't complicated things, but I'm just running out of time. So yeah, I think this should be nearing the end of my allocated slot. Yeah, that will be all for this introduction to Unity workshop. Um, let me just- so that will be all for this one. Yeah, you can always message me on Discord. I go by the name was on the Africacomicade Discord server. You can always message me there for any more clarifications on how to use Unity. Yeah, there are other things that we are going to discuss. Yeah, you can always just message me for any questions, any guidance on any learning material and all that. But for now, this is me saying bye, and yeah, I hope you enjoyed this session. And I'll be seeing you. Peace.